Students, we are going to learn rational numbers. Students, we are going to learn rational numbers. Rational numbers. A number that is either an integer or as a quotient of two integers or terminating and repeating decimals. Is called rational number. The set of rational number is denoted by Q. For example, one 540, 1 by 3, 1 by 9 are rational numbers. Now I am repeating all the things once again. A number that is either an integer or as a quotient of two integers or terminating and repeating decimals is called rational number. The set of rational number is denoted by Q. For example, 1, 540, 1 by 3, 1 by 9 are rational numbers. Now I step down towards the property of rational numbers. What are the properties of rational numbers? Properties of rational number. If A, B, C are three rational numbers, then first, commutative property for addition. Commutative property for addition. A plus B equal to B plus A. Second, associative property for addition. A plus B plus C equal to third. Inverse property for addition. for any rational number A there exists a rational number minus A such that A plus minus A equal to minus A plus A equal to 0, where 0 is the additive identity and minus A is the additive inverse of A and vice versa. Once again, I am repeating the properties. Once again, I am repeating the properties. Property of rational numbers. If A, B, C are three rational numbers, then commutative property for addition is A plus B equal to B plus A. Second, associative property for addition A plus B plus C equal to A plus B plus C. Third, inverse property for addition. For any rational number A, there exists a rational number minus A such that A plus minus A equal to minus A plus A equal to 0, where 0 is the additive identity and minus A is the additive inverse of A and vice versa. Now come to the same property for multiplication. Fourth, property for multiplication. A into B equal to B into A. Associative property for multiplication. A into B into C equal to A into B into C. Inverse property for multiplication. For any rational number A, there exists a rational number 1 upon A such that A into 1 by A equal to 1 by A into A is equal to 1, where 1 is the multiplicative identity. And 1 upon A is the multiplicative inverse of A and vice versa. One upon A is also known as the 1 upon A is also known as reciprocal of A. Now, commutative property for multiplication, A into B equal to B into A. Associative property for multiplication, A into B into C equal to A into B into C. Inverse property for multiplication, for any rational number A, there exists a rational number 1 upon A such that A into 1 upon A equal to 1 upon A into A equal to 1, where 1 is the multiplicative identity and 1 upon A is the multiplicative inverse of A, and vice versa. 1 upon A is also known as reciprocal of A. Reciprocal of A. Now, distributive property. Distributive property for addition over multiplication. A into B plus C equal to A into B plus A into C. This is called distributive property. Now we are going to learn operational properties of the rational number. My next topic is operational property. We are going to learn operational property of rational numbers. Operational properties of rational number. For any two rational numbers A upon B and C upon D. Number 1, addition property. A upon B plus C upon D, that is equal to, your LCM of B and D is BD, AD plus BC. This is the normal addition of fraction. Second, subtraction. A upon B minus C upon D. It is also a normal subtraction. Now, in operational property of rational numbers, for any two rational numbers A upon B and C upon D, addition A upon B plus C upon D, it is normal addition of fractions, and for subtraction it is normal subtraction of fraction. Third, multiplication. A upon B multiplied by C upon D is AC upon BD. You multiply their respective numerators and denominators. Multiplication is just like as A upon B into C upon D. You multiply their numerators AC and their denominator AC upon BD. Fourth is division. A upon B divided by C upon D equal to A upon B multiplied by D upon C, that is equal to AD. A upon B multiplied by D upon C equal to AD upon BC. Should I continue?
Yeah.
Now next one. Next property I am going to discuss with you students, density property of rational numbers. Maybe you are hearing this name, density property of rational number, first time. Some of you are hearing this property first time, but you already do in your previous classes, but you don't know with this name. This is property is the density property of rational numbers. Density property of rational numbers. What is that? You may know. Between any two distinct rational numbers, we can insert so many rational numbers. You can say your number of rational numbers between two distinct rational numbers are infinite. Uncountable rational numbers you can insert. And this property of the rational number is known as the density property of the rational number. For example, for two rational numbers a and b, such that a is less than b. Let q1 is the first rational number. First rational number between a and b. q1 equal to a plus b by 2 implies that a is less than q1 is less than b. Now, second rational number q2 is a plus q1 by 2. This implies that a is less than q2 is less than q1 is less than b. Third, q3 is equal to q1 plus b by 2. This implies that a is less than q2 is less than q1 is less than q3 is less than b, and so on. Students, this kind of property is known as the density property of the rational number. I have discussed this with you with the example. Now, this is your first method. Now, second method, how can you approach second method to find a number of rational numbers between any two given rational numbers? Your method 2. For a is less than q, a is less than b, for any two rational numbers, a upon b and c upon d. Step 1. You find the LCM of b and d. Find LCM of b and d. That is equal to bd. In order to make the same denominator, You multiply first rational number by numerator of first rational number, numerator and denominator of first rational number by d. It is AD by BD and BC by BD. Now you can see that your denominator of both the rational numbers becomes equal, and suppose you want to insert n rational numbers between AD upon BD and BC upon BD, then you multiply numerator and denominator of AD by BD and BC by BD by n plus 1. You can see after doing that you will get n rational number between AD upon BD and BC upon BD. Now second method I am repeating again. For any two rational number A upon B and C upon D, step 1, find LCM of B and D, that is BD. Now you have to make the denominator of both the rational numbers same. So you multiply your numerator and denominator of first and second rational number, first rational number by D and second rational number by B. And after that, suppose you want to insert n rational numbers between AD by BD and BC by BD, then you multiply numerator and denominator of AD by BD and BC by BD by n plus 1. In this way, by this procedure, you can get n rational numbers between two given rational numbers. Now I am taking example. Illustration. Find 7 rational numbers between between 1/6 and 5.21. Solution. Let Q1 is the method 1. Let Q1 is the first rational number. Between 1/6 and 5.21. LCM of step 1. This is not in first method. Now Q1 equal to now Q1 equal to 1/6 plus 5/21 by 2. That is equal to LCM of 6 and 21 is 42. 7 plus 10 into 1 by 2. It is 17 by 84. Now Q2, that is equal to 1 by 6 plus 17 by 84 by 2. It is equal to 1 by 2. Your LCM is 84. (14 plus 17), that is equal to 31 upon 168. Now Q3 equal to 1 by 2, 17 by 84 plus 5 by 21. That is equal to 1 by 2. Your LCM is 84, 17 plus 20, that is equal to 37 by 168. Similarly, you can find Q4, Q5, Q6 and Q7. This is the first method, students, by which you can insert 7 rational numbers between 2 rational numbers 1 by 6 and 5 by 21. Let Q1 is the first rational number between these two given rational numbers. So 1 by 6 is less than Q1, is less than 5 by 21. One by 6 is less than Q1, that is 17 by 84 is less than 5 by 21. So in this way you can proceed by using this method. Now second method. Now I am explaining second method to insert 7 rational numbers between these two given rational numbers. Method 2. Let given rational numbers are (1 by 6) and 5 by 21. In this method, step 1, find LCM of 6 and 21, that is 42. Now step 2, make the denominator of both rational number as 42, and for that, in first rational number, in order to make the denominator 42, you have to multiply the numerator and denominator of the rational number 1 by 6 by 7. So we reach to step 3, that becomes 7 by 42. In the same way you multiply the numerator and denominator. Just to bring the denominator as 42, you multiply numerator and denominator of 5 by 21 by 2, and your that number is 10 by 42. Now you count, you remember how many rational numbers you are going to insert between these two rational numbers. That is 7. So I have given you the formula for that. You multiply it by, suppose you want to insert n rational numbers, then you multiply their numerators and denominators by n plus 1. Here you are going to insert 7 rational numbers. Therefore, you multiply the numerator and denominator of both the rational numbers by 8. So 7 into step 4, we reach to step 4. 7 into 8 upon 42 into 8, and here 10 into 8 upon 42 into 8. By this, it is 56 upon 336 and 80 upon 336. Now you can insert so many rational numbers between these two rational numbers, like 57 upon 336, 58 upon 336, 59 upon 336, 60 upon 336, 61 upon 336, 62 upon 336, 63 upon 336. So in this way, you can insert 7 rational numbers between two given rational numbers 1 by 6 and 5.21. Now I am giving you some question to solve. Question number 1. Assignment. This is the assignment session. Assignment. Question number 1. Find 5 rational number between 4 and 5. Find 6 rational number between 3 and 4. Third, find 5 rational numbers between 3 by 5 and 4 by 5. That's all.